All right, for the arc addition postulate, the measure of the arc formed by two adjacent arcs is the sum of the measures of the two adjacent arcs. So if I have the measure of angle AB, the measure of angle B plus what gives us AC? What? I thought I heard it. BC. So if I add AB and BC together, I get this whole arc. Okay? Just like when we added the segments together, we would get the big segment. Just like when we added the little baby angles, adjacent angles together, we would get the big angle. Same thing. Okay. Find the measure of each arc. Oh. Okay, did we say that the measure of the central angle has to match the measure of the arc? Okay, we did say that. I have it written down. Okay, it was right here. So remember that the measure of the central angle, DEF, was equal to the measure of the arc, DF. Okay? Okay, we said that it was just yesterday. So, if I know the measure of angle BOC, you guys writing this down? I know that the measure of arc BC has to be equal to the measure of its central angle, angle BOC. What is the measure of angle BOC? Okay, what about BD?
32 plus 58.
90. Okay, so 32 plus 50. I know it looks bigger than that. This is just proof that you can't like trust the way that a picture is gone. You can only trust the markings and how things are labeled. Okay? Because that definitely looks bigger than 90 degrees, doesn't it? All right, what about the measure of angle ABC? Sorry, not ABC, the arc ABC.
180.
It has to be 180 because ABC is a semicircle.
How do we know that there's? We have to write it that way because it looks like it's half.
Because no, not because it looks like it, because AC is a chord that goes through the center, so it has to be a diameter. Yep.
Do we have to write it like that?
What?
Like in ABC.
Yeah, this is, okay. Hey, the question was, do we have to write the M? ABC is the arc. The measure of ABC is the length of the, not the length, I'm sorry, the measure of the arc. It just distinguishes it from the figure. Okay, so what about arc AB?
So we do since we do the 180 minus the 32.
Hit it.
So we do 180 minus the 32 because those two arcs make it.
Okay, perfect. I'm convinced. So what is 180 minus 32? 148. Okay. Okay, I want you to do example 6. Okay, what did we get for the measure of xy? Okay, how did you get that?
56 plus 40.
Okay. What was that, 96?
Yeah.
Okay. And then, do you need more time for the next one, or do you have it? Okay, what did we get for dxm? This one's kind of tricky. All right. Hey guys, do you see that I have intersecting lines here and here?
Yeah.
Okay, so I have a pair of vertical angles here and another pair here. Does everybody see that?
Yes.
So if this one is 96, what is this one? Also 96. Okay. And then if I take away the 96 from 180, what do I get for this red one?
Oh, it's like 84.
Is it 84? That sounds about right. Okay. So if I want DXM, DXM is all of this. So what am I adding together? 56 plus, okay. 56 plus 84 plus 96 to what? Okay. So we're going to have to activate prior knowledge like vertical angles and the angle addition postulate and all that fun stuff. All right, cool. All right, guys, this is really easy. So this formula looks crazy, but it's not. It's actually really simple. So we know how to find arc measures. Arc measures are in degrees. They match the central angle for that corresponding arc, right? And arc length is part of the circumference, okay? So the whole circumference is 2 pi r. Whole circumference is 2 pi r. And we only want a fraction of it. So if we take the angle of the arc and divide it by 360, that tells us how much of the circle, how much of the circumference we actually want. So if we did like 90 over 360, isn't that just 1/4? So we would just do 1/4 of the circumference. Is this making sense? Okay, perfect. So using that cute little formula, we're going to find the length of xy. That's this one right here. So the length of xy is the measure of the arc. How much is that arc? This one is 90, so its central angle is 90, so its arc measure is 90. So 90 degrees out of the 360 total degrees times 2 pi r. So what is our radius?
8.
Yeah. So times 2 times pi times 8. Okay, leave it in terms of pi. So the parts that you put in the calculator are the 90 over 360 times 2 times 8. Leave the pi out of it.
That pi is really good. Can we make it 1/4?
Yeah, you can make it 1/4. They won't all simplify nice like that. So I'm going to type it in the way that will work every time. 90 divided by 360 times 2 times 8. Is it 8? Okay, so that gives me 4. 4 pi. 4 pi inches.
We don't have to find the exact.
This is the exact. It says leave your answer in terms of pi. This is the exact.
this one down here. Got you.
All right. Yeah, try the last one. Go ahead and try the last one. Okay, it's saying ADB, not AB. Be careful.
Supposed to be a line here.
No. Okay, be careful. You're finding the major arc, not the minor arc AB. So what is the measure of that central angle? I heard 210. So 360 minus 150 is 210. Okay, so we're doing 210 over 360 times 2 pi. What's our radius? 18. I'm getting 21 pi. 21 pi centimeters. Okay, questions?
No, ma'am.
Okay, thank you.